Good day, ladies and gentlemen. Today we want to complete the remaining task ahead of us. And we're going to start with the task 5 called execute. Remember that this task has to do with the permission. And before I actually talk about this task, I want to first of all make us understand the concept behind permission. Actually, what do we need permission for? I have this background check that Linux operating system is a multi-user operating system, meaning that more than one person can use Linux operating system simultaneously, and then hence there are three levels of users in a typical Linux operating system. One is the user itself, that's the owner. The second is group, and the third part is others. You can check that out by simply going to your Google and then type permission in Linux. Now, if you open this very file, you can see something here, how to read, write, and change in Linux. Just open this. Now, if you look at these, what I've just stated so far, Linux is a clone of Unix, the multi-user operating system, which can be accessed by many users simultaneously. Linux can also be used in mainframe, and the rest of the world is there. Now, if you come down here, it is divided into two categories. We have the ownership and the permission. That's two levels of authorizations in Linux operating system. Now, if this is a very good resource, if you take your time to go through it, you have a lot of understanding about Linux and its permission stuff. But let me just try to break it down before we go into the main task ahead of us. Now, Linux has three levels of users or ownership, right? And the first one here is users, the second one is called group, and the third one is called others. All right. So remember the last time when we were dealing with chmodu plus x, I told you I'm going to explain that later. The U simply stands for user, which means the owner of the file. Let's say when you create a file, like you type something like touch man or touch file, you own the file, right? But you can choose to give that file to a group of users on the Linux or others to actually access your work. Now let's break it down to something like a Microsoft Word, which is very, very usable and known to everybody. Let's say you have a file in your system and then you want to give it out to a specific person, all right? What will you do? You put your file with a password such that if I don't give you the authority or the right to that password, it cannot open it. That's like a permission, right? That same scenario is applied here in a synopsis. Okay, say user is the owner of the file. By default, the person who creates a file becomes the owner. All right, now let's look at group first. In the very first state, a user group can contain multiple users. All users belonging to a group will have the same Linux group permission access to the file. Now let's say that I have, like, let's say 50 persons working on the same system with me. Now I create a file, I'm the owner of the file, right? And out of these 50 persons, I'm left with 49. If I take myself out, then I try to group those 55. Let me say I group 10. That's a group, and call them group 1. All right. Now, if I create a file and I choose to share it with that group, I have to grant a permission access for that group to be able to access the file. All right. While the remaining people that have not fixed them in a group are what? They are others. I think that three levels is clear enough. Myself, I'm the user, are the owner of the file. The group of persons that are working with me, which I've actually made them, or they have formed a group by themselves and call themselves group 1. That's a group that I can share my file to. And then the other people who refuse to be the owner of the file and refuse to be in the group are definitely others, which I can still share my file to. Now, take those three keys and then let's move ahead. Now, when you talk about permission in Linux, there are three major things that you have to associate permission with. The first one is the read, the second one is the write, and the third one is execute. What is read? Now, when people talk about reading computer system, it doesn't really mean reading text, like reading letters or something like that. That's not about text or reading alone. That's not about reading. Now, what is about reading? Reading is anything that you can take out from the system. For instance, I'm watching a film, I'm actually reading. I'm listening to a voice note, I'm actually reading. For instance, I'm talking to you, you're listening to me right now, you're reading from me. That's read. So it doesn't really necessitate like letters or something like that, or characters, okay? Then write is actually when you're giving in something. I'm writing to the system. When you're writing something, please come to me. That process you're writing. As I'm talking to you right now, I'm writing to you, okay? That is right. And then execute means a file that has the ability to perform an action based on commands that is associated with the file. Now, every file can have 2 to 3 permissions, or 2 to 3, even one, two, or three associates. The file can be readable only. It can be writable. It can be what? Executable. So let's go down. Let's go down now. For a file to have a read permission, that means there is a value that is associated to that file. Same thing with write, same thing with execute. Please take your time to go through this very site. You will have a better understanding because I'm trying to rush over. I'm sorry about that. Okay, look at this. User has the ability to read, write, and execute based on permission. Group has the same, and the all, that the remaining people have the same context depending on what? Permission. Now, each time you list your file, let's take for instance, let me just launch my sandbox and show you something very quickly. Okay, let me just quickly cd into the directory we're using this file, and then let me just list a long format. Okay, now if you look at this very place, we have drwx and the rest of them. The D actually stands for directory, and we have the minus starting this permission. It's actually the file. Let's come here and see if that makes sense. Just take a look at this place. File types and access permission. We have the rw minus rw, where the r stands for read, w stands for write, and then x stands for execute. I'm gonna work on that right now. Here we have highlighted rw minus r, and it's weird looking code, right? It's the one that tells us about the Unix permission given to the owner, group owner, user group, and the world, that's others. Okay, now this will actually take us to a little concept of number system called binary conversions to decimal, right? Anytime you convert a value from binary to decimal, or decimal to binaries, it's just a change of base, right? Now let's have a look at this. If you don't grant permission to anybody, either user or group, you don't grant permission, that is no permission to either user or group or others, it is 0, and the symbol is going to be 3 dash, because the R is 0, W is 0, and the X is actually 0. Sorry, I'm taking a lot of time to explain this. I think I'm going to explain better. Okay, now if I write 1 as the value, that means that I'm only granting executable permission, which is X. The R is not granted, the W is not granted, and the X is only granted. That's 1. If I should use 2, it means only W is granted. If I should use 3, it means W and X, all the symbols is right here. But let's see how to understand the concept of these values. Now, take your X to be 1, okay? Take your W to be 2, and take your R to be 4. X to be 1, W to be 2, and then R to be 4. If you look at the progression of decimal to binary, that is the progression. I'm gonna explain that later, or probably with a live session. If you don't understand, you can call me to have a chat with you. I'll explain that in details with a whiteboard. But for now, let's try to continue and forge ahead. Okay, so if peradventure you are asked to grant permission for only read and execute, that is R and X, what comes to your mind is the value of R is 4, and the value of X is actually what? 1. So 4 plus 1 becomes 5. That grants permission for read and execute. Is that clear? Now, if you're asked to grant a permission for only R and W, just like this, now what comes to your mind is that R is 4, W is 2. So 4 plus 2 becomes 6. If you look at here, we have 6. What if it's a complete read, write, and execute that we're seeing here? That is 4 plus 2 plus 1. We add them together, it becomes 7. That's a shorter way to understand that. But there are binary values. 4 is 100. That means that if you say 100, it simply means that your write is 0, your X is 0, while your what? Read is 1. If you convert 100 from binary to decimal, that's going to give you what? 4 as a value. All right. Now, I'm not gonna go much deeper. If you look at all this, you will have a more understanding. But let me just explain one last concept. In my previous video, we've been using chmod u plus x, right? If you look at this very place, the symbolic mode in Linux, the u we normally use is for the u. So when you say u plus x, it means add executable permission to the user. If I should say g plus x, it means add executable permission to what? The group. If I say a plus x, it means add executable permission to what? All of us. The user, the group, and others. All right? Just take your time. Practice them one after the other. I'm sure you will understand better. For now, let's get started from where we stopped. Okay. Now, right here, you're asked to write a script that adds execute permission to the owner of the file. Hello. Now, let's do this practically before we actually go into saving it in the shebang and then pushing our code and all that concept we normally do. So first, let's create a file. Ensure you cd into your directory, or let's just do that. Cd into ALX system in devop. Enter. Do you have any file in here? Yeah, we have shell permission. Let's cd into our shell permission. Right. Now let's create the file called hello. So we touch hello. All right. And the first thing we want to do is actually check the permissions that was granted before now. So if we say ls minus l to c, okay, hello here has the permission rw, that's read and write. The third one is dash. That means that the user does not have the executable permission. You can only read and write to this file. Okay. Now the second one here is the r dash dash. That's for the group. The group can only read the content of this file, but cannot either write to it or execute. The person doesn't have a password, take it that way. The same thing applicable to others. All right. So let's try to remove this write permission. If you can take your mind back, that's supposed to be what? 4, because we have only r. That's 4, 4, 4. 4 for group, 4 for users, 4 for others. So we have to write chmod change mode and then have 444. All right, space and then the file name hello. Okay, enter. Now let's check again what happens. So we list minus l. Now you can see that hello becomes r because you've removed the write permission. Now as it stands, you cannot write to that file. Okay, let's try to write something into that file and see if it's gonna work, if this thing is actually true or not. So let's say emacs hello. Okay, so let's just write something. Let's say this is trial. Now what happens if you look at the buffer? It's telling you that buffer is read only. Now you cannot write anything to this file. You can only read from the file because you've removed what? The permission to write. I hope it's making a lot of sense now. So let's just move out of here since we cannot write something. So let's now see how to write something into it. Okay, so we now have let's grant the write permission. You will say chmod to write permission. That means the r is going to be active, the w is going to be active, and the x is going to be off. That is not going to be active. So we have the 4 plus 2, that becomes 6. So we have 644, and then with the file name hello. Right, now let's list again and check what happens to this file. Minus l. All right, you can see the r and w is active. So let's see if we can write into the file again. emacs hello. Okay, so let's try to write something. Let's say this is trial. Okay, you can see we're now writing something into the file hello. So we can now save this and then we can cut the file to see if there is something written inside. Of course, we have our this is trial. You can see that from here. This is trial. I didn't have a new line, that's why it's written together with the root directory. Okay, now the next thing we want to do is let's see how to grant executable permission. But what if you want to execute? What will happen? Let's say I try to execute that file called hello. All right, and then if I enter, it's telling me permission denied because I didn't grant permission for hello. All right, I think you're understanding the concept now. All right, so since we have the understanding, the clarity of what this permission does, how to use it, how to utilize it, when to use it and when not to use it, let's now start working on the tasks ahead. I hope the video is not too long. Sorry if it's long. I'm trying to make you understand the concept deeply. Okay. It says here, okay, write a script that add execute permission to the owner of the file. It's very simple. It's just to make that your X to be present in your file. So for us to do that, it's just for us to say chmod. Now, when you're adding permission, it's either you use 7 or you use u, because you say u user plus X. That's all. That's fine. And then you write the hello. Or we can choose to say 744, and then you put the hello. That's still fine. Even if you use 764, it's still fine, as long as you don't grant executing permission to the rest. It's gonna be fine. All right. So since we have the knowledge of what it's supposed to do, first we have to vi or use emacs as the case may be to, let's get the file name 5 executes. All right, let's copy these and then add that to our vi. All right, so in here we have our ch. So we can start with the bash. Then we write chmod. Then you can use u plus x, or you can choose to use 744, 764, 766. Any of those concepts still, and as long as you don't grant permission for others, just the user is what they're looking for. Then you have hello, and then you can save this, escape, colon wq for vi users. When you're done with that part, you have to execute or grant executing permission here again. So you have chmod again, u plus x, and then the file name, that is 5 execute. All right, enter. You can push your code to GitHub, check your code is gonna work. Right now, for you to verify that you've done the right thing, you can simply list, all right, all files that has executable permission must be green. So if you can enter this, you can see that all files that I execute is green. The hello that I didn't grant execution permission, which you can see here is not granted, it's actually what? White. Take note of those color codes. All right, we're done with that one. So we go to the next task here. The next task says write a script that adds execute permission to the owner of the file and the group owner and read permission to others. All right, now two things are involved here. The first, the owner is going to have the executing permission. The group is also going to have the executing permission. And then the last is the user is going to have just the read permission. Now, how is that going to work? 7 is going to be given to the user, which is complete RWX. And then 7 is also going to be given to your group owner, which is complete RWX2. But for the users, for the other users, it's going to be what? Just 4, which is R alone. I think that's very simple. So let's try that first. If you want to confirm if you are doing the right thing, you can simply say that I want to grant permission to only users that have something like chmod 77 and then 4 and then hello. All right, if you enter this and then if you list this in a long format, you can see that hello has an RWX for users, for group, and then for what? Others. So you've gotten your code simply vi again, and then let's get our file name. The file name is supposed to be 6 multiple permissions, right? And then we copy this, paste it right here, and then inside here first you start with your about that escape key, and then start with your bash in bash, then the code chmod 77 and then hello. You can now save this, then grant permission here again chmod u plus x, and then the file name was 6 multiple, enter, git add, git commit, and then git push. That's gonna save you. Right, okay, let's go to the next one. Everybody write a script that adds execution permission to the owner, the group owner, and the others to the file hello. I just hope that is very very good. It's just very simple. That's 777 to everybody. That's gonna work. Let's try to work fast. 777, you know what to do with the rest. Okay, we go to task 8. It says write a script that sets the permission to the file hello as follows. Note, owner, no permission, that's 0. Group, no permission at all, that's 0 also. Then others, all the permissions. Okay, let's see how to do that. Let's see how to do that. That's chmod. For the users is 0. For the group is 0, and then for others has all permissions. That means I'm going to give them 7, and then the file is hello. Enter. Sorry about that. Let's redo that again. Chmod 007, then hello, file name, enter. Let's see if that works. So list and then -l. Okay, you can see it is 000, but the others have rwx. So I'm sure if you push your code, that's just gonna work. You know what to do next. Vi, let's try to do that together. Then get the file name. This is gonna explain better if you look at this. It's giving you the right thing to do there. So let's copy this and then simply paste it here. Enter and hash and then hello as the file name. And now save that. Okay. Then chmod again to grant permission. You here is always use x, use 76 or anything you like, it's still fine. And then the name, I think that was 8 James Bond, right? Fine. Enter. Push your code, everything's gonna work fine. So let me clear the screen, it's getting bulky. Right, the next one here says John Joe. I love this name, John Dio. All right, write a script that sets the mood to the file hello to this. All right, it's given here rwx. Note that is 7. I'm sure you understand that rwx is 7 for the users. R-x, that means this is 4, this is 0, this is 1. So 4 plus 1 becomes 5. Is that true? Yes. We have 7, 5, take that down. And then we have here to be dash 2 and 1. That's what? That's 3. You understand that? This is 4, this is 2, this is 1. So we have 7, 5, and 3. Let's confirm that first. So let's have chmod 753. Is that true? Then the file name hello. Enter. Let's list that. -l. Okay. We have rwx. So let's look at it. We have here rwx. That's fine. And then the next one here we have r minus x. So if you look at here, we have r minus x. So we check again. We have minus wx. So if you look at here, we have what? Minus wx. So that's fine. That's cool. We are done with that very task. You know what to do. Open your VI, put the code inside, grant executable permission, and then push your code. Everything's gonna work fine. And let's clear the screen again. All right, let's go to the next one, number 10. Write a script that sets the mood of the file hello to the same as Ole's mood. All right, and then the file hello will be in the working directory, and the file Ole will be in the working directory. Now, what you're asked to do is that these two files must have the same properties. Okay. Now, what that means is that the same file, the same name you're creating, the same permission you're setting for hello must be the same name or permission you're setting for what? Ole. And if you come down here, it is given right here. This is rw minus rw minus r. So that means it's going to be 4 plus 2, 6. 4 plus 2, 6, and then 4. So you have 6, 6, 4. Now, let's see how to grant permission for the two of them. All right, let me quickly go to my sandbox and do that. First, let's do a practical approach. You have a low, right? Let's now create a file again. Let's touch a file called Ole. That's the file name. Ole means thief. In my language, Ole means thief. Okay, so let's try to create grant permission for the two of them at the same time. All right. Okay, so to do that, one file must actually reference the other. Okay, but let's assume we don't actually know what to do at this level. So let's just check. Now, let's go back to the question again. It says, write a script that sets the mode of the file hello the same as Ole. And that means Ole already have a mode in this very mode. So let's write Ole's mode. Okay. So the mode is actually 6. Let's get back there again. I think it's 664. Yeah. I'm just trying to show you how that works. So Ole is gonna be chmod 664 Ole. All right. Now we want our hello to have the same permission as of Ole. But now we don't know, because whenever I say we move out of the exact command, we need a flag. I don't want to change the mode only, but I want to make the mode to be as same as Ole. That's a flag. So we simply know how to find a flag command. chmod. You have to sit down and then go through this resources one by one to actually find a flag that matches what you're looking for. Okay. If you come down here, I don't want to waste much time. You can see here, reference, use R files mode instead of mode value. That means use the reference of R file. All right. Look at that again. Use R files mode. That means use the R file. There simply means the file you want to reference. So it becomes dash dash reference equals to the file you want to reference, and then the file you want the reference to take effect. So let's see how that works before we actually write our code. So let's quit this. We're gonna say chmod. I don't need a mode of myself, but instead reference ence equal to Ole. All right, and then change that to what? Hello. Okay, enter. All right, let's see if that works. Minus L. Okay, now if you look at here, we have Ole that bears the name rw. Now our file is changed to the same permission. All right, I hope that is very clear. So we've gotten our result. We open our vi or emacs depending on the one you want to use. Then let's get the file name. I think that was mirror permission. Yeah, that's correct. And then let's copy this here and then let's paste it right here. Enter. Hash. Okay, we have chmod friends equals to Ole. Then hello is the file name we want to friends. Then we can save that. Okay. The next thing here is to grant permission over here. chmod plus x, and then the file name is 10 mirror permission. Okay. Push your code, check your code, everything's gonna work fine, and that's okay with that very task. The next one here says create a script that adds execute permission to all subdirectories of the current directory for the owner, the group, the owner, and all others. Regular files should not be changed. Now that's a flag again. Okay, that leads us to another flag. You have to sit down and actually go through those flags one after the other to get real understanding. But let me just try and give you the result. Let's open our sandbox. Let me clear this. Okay, and then let's vi into the file name called 11 directories permission. Okay, let's press that and then enter. All right, and then we have chmod. Now if you look at the flags very well, all right, if you look at the flags, the right answer to that question is minus capital R. And so you look at the flags, you understand what I'm doing right here, and then we're adding the executable permissions to all that plus X. Sorry, capital X. Then you save your code, WQ, and then grant permission chmod u plus X. File name, I think it's 11. Push that code to your GitHub and everything's gonna work fine. The next one here says mode directories. Create a script that creates a directory called my directory with the permission 751 in the working directory. I'm sure we can do that. It's quite very simple. We create the directory called mkdir. We know how to do that. Then the file name given is what? It's called my dir. So we have my underscore dir. Right, enter. Permission we're supposed to grant is what? It's 751. Okay, that's very simple. It's been given. So chmod 751 and then my directory. Enter. that's done, you can now git push, git add, git commit. You don't need to grant permission again in this very task. Okay. All right. 13 as the last. Here is advanced. So 13 is the last for us. Write a script that changes the group owner to school for the file hello. All right. If you go back to our resources, the commands that we're supposed to use, I'm sure you remember that we have something like this. Let's just man ch chgpr, right? grp rather, chgrp. Now it says change group ownership. So now how do you change that? It's supposed to be changed option, the group, and the file. The option here is the flag. Okay, so we have change group. If you have an option like flag, I can use it. You don't have, I have to use the group and then the file name. So let's quickly do that. That's supposed to be grp change group, and then the group name was given here as what? I think it's school. Yeah, school, and then the file is hello. We have this chach file name hello, right? Put that in your vi, and you're done with that. So vi or Emacs, anyone you prefer. Let's copy the file name, we paste here, enter. Okay, then we have chgrp change group school, then give them the file hello, right? Okay, wq save, and then first you have to change permission, right? Each time you use the Shiba, you must always grant permission. Don't forget. 18 space enter. Do your git add, git commit, git push, and then that very tag is up. The next one here says write a script that changes the owner. Oh, so sorry. This is advanced task. I'm not gonna run the advanced tasks for now. If you want me to do that, drop a comment or you can contact me. I will definitely be glad to come and assist you. It's just very simple. All these ones are very simple to walk through. You can see everything is checked 100%. So I'm sure you can do that yourself. Do have a lovely time out, and thank you for having me around. Ensure you subscribe, share, and like this video. See you in my next video. Bye for now.